Hi everyone, another day, another topic. Grade 12 physics, final exam revision questions and answers. We are getting these questions from past papers and day 7. Today's topic is mechanics. So first of all, please go to PDF format just from video link and get your questions, try first. And then comment, get answers and you can correct your answers. Question 1. The weight of an object on the surface of the earth is W. What will be the weight of object on the surface of another planet, same mass as that of the Earth, but twice the radius of the Earth? So this is our question. So let's see what they are asking. First of all, let's write it down. Let's draw what they are asking. You have Earth and with what is mass? Let's say with M. And then we have another planet, but twice radius. So it is bigger than Earth. It is another planet. We don't know, let's say planet X. And radius is 2r. We have 2r. Mass is still same, but radius of Earth is r. So if you are writing weight formula or gravitational force, another name, weight or gravitational force, what was our formula? G, constant number, times mass of the object and mass of Earth and radius of Earth square. This is our formula. If you have this all, you have W, but let's say Wx, so weight of object on planet X, let's say. So we have same object, so G is constant already, it's still same. Mass of object still M, mass of planet still M, but what we have 2r. So if you make 2r, what's going to happen now? Let's see. G times M over 4r squared. So all together, we know G times M r squared. What we know? W. So if you write W there, your answer is W over 4. W over 4 answer is A. I hope it is clear. Another easy way. So if you have double radius, you can just square root, making 4. And then if you have 4, 1, right? Just swap this 2. This is easy way, 1 over 4. 1 over 4 W, because when you have more distance between center of planet and object, getting less force, less gravitational force. If you make double, 1 over 4. If you 3r, 1 over 9. Easy way like that, but if you want to see with long process, you can see also. All right, let's continue with next question. I hope you did try. I hope your answer is correct. Please don't forget to go to get your questions and try. Question 2. Answer is A, yes. And then another question. Question 2 is coming. We have 2 kg object block we have, and then rough horizontal surface, we have friction. Is connected to a 2 kg block, all right, by a light, okay, string, all right, with constant speeds, all right. What does it mean, constant speed? If you say constant speed, acceleration is 0. So you must use Newton's first law for your calculations because acceleration is 0. And then you have applied force, 29.6 horizontal surface, horizontal force to the right, okay, frictional force, all right. Object moving to the right. And then what's our question 2.1? Newton's second law. Asking you Newton's second law, all right? So Newton's second law, when a resultant net force acts on an object, the object will exert in direction of force with acceleration that is directly proportional to the force and inversely proportional to the mass of the object. Or another definition here, all definitions we should know. All right, let's continue with next question. Let's see what they ask you. Draw a labeled free body diagram for 8 kg. Okay, so what forces we have on this 8 kg object? As you see, we have applied force this way and tension force that way. On the object we can draw. As you know, we have force diagram and free body diagram. Now they're asking you free body diagram. If they ask you force diagram, you should draw with box, but now just dot is fine. So we have tension force this way, apply force is already given, and friction force on the surface we have this way, We have friction force, you can show with small f. And then gravitational force from center of object, it is going down, W or Fg, you can show. And normal force from surface and perpendicular to surface, we have normal force. When you draw free body diagram, you are drawing total, how many? 1, 2, 3, 4, 5 different forces. But to get full mark, please write just all names of forces with symbols. You can use N, Fn, normal, you just write all names, and then friction force given, and then everything you should write, all forces name you should write to get full mark. Let's continue with new question. This is 5 marks. As you see, we have 5 marks, 5 forces. If you just forget about all symbols, names, if you forget about labeling, you are going to get -1 mark. Please don't forget that. Calculate the tension force. Okay, we are looking for tension force now. So Newton's first law we can use, even Newton's second law, but it's fine because acceleration is 0. You are coming back to Newton's second law. F net equals m times r, F net equals 0, or F minus friction force plus tension force, because applied force and tension force, friction force, opposite direction, as you see. Tension force is here. And from free body diagram also, you remember that. Friction force this way, F minus friction force plus tension force. And you can write MA, but what we know, acceleration is 0. Acceleration is 0, please remember that. After that, you can write applied force is 29,6 minus 10. How we know it is 10? It is given, guys. Friction force is given, it is easy. Otherwise, you should calculate with m times g from normal force, coefficient number times. So otherwise, you should calculate like this. F is equal to coefficient number times normal force. For this object, normal force is mg, coefficient number times m times g. You should calculate, but now it is easy because it is given already. So friction force 10 minus tension force equals 0, and you can get tension force by using 8 kg object. Another option we have, if you want, you can use 2 kgs object. 2 kg objects we can use to get tension force. What forces we have on 2 kg? As you see, we have gravitational force from center of object. We have gravitational force, or weight you can say, and tension force. And you can write F net equals m times a. F net equals 0. F net tension force minus weight is equal to 0. Any of this getting 1 mark. And then weight going other side, tension force is equal to weight is equal to m times g. Why tension first? Because object going this way. They said to the right. So it's going up, accelerate, no, not accelerate, going with constant velocity, going this way. Because of that, tension minus weight equals 0. And m times g, you are getting 19.6 newtons, same result we are getting, guys. All right, question 2.3 also done. I hope everything is fine so far, because how many times we answer this kind of questions? Huh? So let's continue. Now something is getting different. 19,6 apply force is now increased to 50 newtons. So now accelerating, all right, not constant velocity anymore. That just here's constant speed, but now 19.6 change to 50 newtons, apply force increase, and then apply Newton's second law to each block and calculate the magnitude of acceleration of the block 8 kg. Okay, that's our question. Same process, but now not Newton's first law, Newton's second law we are using. They are saying already here, Newton's, just apply Newton's first law, sorry, Newton's second law, 2.4, apply Newton's second law to each block and calculate the magnitude of acceleration of 8 kg. So for this kind of questions, apply for Newton's second law, you should apply for 8 kg and 2 kg, both of them, and you combine two equations. First of all, F net is equal to m times a, Newton's second law, and F minus F plus tension is equal to m times a. You remember the same thing, right? But it was 0 before, but now m times a. So F apply is 50 now, because they said increase to 50 newtons. F apply is 50 newtons. And minus tension force, friction force, still same. And then minus tension force. Now tension force. So you are writing this equation now, 40 minus, because 50 minus 10 getting 40, 40 minus tension force is equal to 8A. Second step, for 2 kg, F net is equal to M times A. As we see, tension force always pulling, we know that, right? And tension minus mg, mg is weight, as you know, gravitational force. Tension minus mg is equal to M times A. So tension minus 2 times 9.8 is equal to 2A. So this is our another equation. And from now, what can we do? We combine these two equations, we combine. How they combine it? They just add. So you can use different methods to combine them. Tension force, 40 minus tension force is equal to 8A. And write another one. What we have, tension minus 2 times 9.8 is equal to 19.6. 19.6 is equal to 2A. If you add them all, what we are getting, tension force, negative, positive, just cancel each other. And 40 minus 19.6 equals 10A. So they are using this method now. As you see, 40 minus 19.6 is equal to 10A. 20,4 equals 10A, as NA is equal to 2,04. We have another option to combine them. Sometimes I'm using that option also. You can just take T from here and change with 8A. So you can just take other side, T other side. 40 minus 8A is equal to tension force. This is a long way, but which one is easy for you can use. Tension force is equal to 40 minus 8A. So when you get this equation, you can write for T 40 minus 8A. So 40, I'm using this equation, 40 minus 8A minus what we have, M times G. M times G is equal to 2 times 9.8 equals 2A. And from now, what I am doing, I'm taking 2A other side, and then finally, same step, same thing coming. 40 minus 19.6 is equal to 10A. This is another option to calculate. As you see, you are coming to same step. From now, you can calculate. They said magnitude. Because of that, you don't have to give direction. For acceleration, okay, it's taking time. Let's continue with next one. 242. Tension force. We are looking for tension force just for 2 marks. Why? Because tension, how many marks? Yeah, 2 marks only, because you know already acceleration, and then you can use with any two, first equation or second one, tension minus 2 times 9.8. So tension minus mg using this one. So tension minus mg, tension minus 2 times 9.8 is equal to 2A. You know A already, just put A there in that equation and you can get, this is our first option. Or you can use second one to get tension force. Tension force, we can give which one asking? String, we cannot give direction because if they ask for 2, it's going up. For this one going to the left. So you can just leave it with direction. 2 marks, question, tension force, done. So mechanics, question 2, done. You know what you are gonna do, please don't forget. So next lesson, we are gonna carry on with electromagnetism, day 8 questions. See you next lesson, everyone. Have a nice day. Please study, please answer all daily questions.